Hello students, welcome back. In this video, we're going to begin our puzzle platformer Light Steps. We're going to focus on two main things here in this video. The first being our world. So what do we want our game world to look like? What kind of feelings are we trying to get across to our player as they play Light Steps? So we'll set the background color, we'll set where our platforms exist in this world that our little player object can move and jump from. And then we'll work on that player object. So how does our player move and interact with that world that we place them in? So let's head to our computer screen and we'll dive right into Light Steps. So I have my web browser open here, and I'm going to go to vscode.dev in the web browser. I'm going to use a web-based IDE, so no software downloads needed, no setup required. We can code everything right here in the browser. Of course, if you have your own IDE, you have something downloaded, feel free to use that. You absolutely can. But here in vscode.dev, I am going to come over to the Open Folder button, and I am going to go to my desktop, which is where my Light Steps folder is, right here. I'm going to click it and select it. And we will allow, and you can trust the author of these files because that author is me. I think you can trust me. I hope you can trust me. And when we open it, we get 8 lesson folders over here in our folder structure. Each lesson has 2 files in it, a final and starter file. So for each one of these lessons that we're going to do together, I give you the starter file, which we are going to go through and code together, and then I give you the final completed version of that code. I give you the final version, that way you have it, and you can reference it, and you can take a look at it. That way if you find yourself stumped or stuck or falling a little bit behind here in the starter code, just go to the final code, see what it's supposed to look like. Take a look at the line of code that you're missing, and then add it to your starter file. All right, but we are going to work out of Lesson 1's starter file because we're going to put our fingers on the keyboard. We are going to do the work of typing out some of these lines of code. That's where the real learning takes place. So with this open, I'm now going to minimize our browser, and I'm going to go to my Light Steps folder, and I'm actually going to open our Lesson 1 starter file directly. And so when I do this, it's going to open right up in the browser, and look, we have Light Steps. Or something like Light Steps. Really, I'm hitting the keyboard. There's no movement, so I'm assuming this is my little player guy. He can't move around at all, which sort of stinks. The world looks very purplish, which, you know, I love purple. It's my favorite color, but it's not the mood that I'm looking for here. And our HUD just says game name. So there's a lot of work that needs to be done to turn this into some playable version of Light Steps. And we're going to do that by diving into Lesson 1's code. But before we do, let's overview what's in this starter file, because I want to make sure we get a good understanding of what we're doing here. To begin, we have an HTML file. An HTML, or hypertext markup language, is the language of the internet. It's what all of the content that you see on the internet is written with. And this HTML language, hypertext markup language, is built up of these things called tags. So I have a head tag, here's a style tag, here is a title tag. Now, with tags, you typically open a tag, I open the title tag, and you close a tag. There I'm closing the title tag. So the opening tag and the closing tag. And you put content inside of the tags. So right here inside of the title tag is Light Steps. That's our content. And if you notice right here up in our little tab up here, it says Light Steps. So if I change the content that's on our website will change. So I'll put Mike and I'll click, and here I'll hit save. And now if I refresh my page, that content changes. Awesome. So that's a really bad name for our title here. So let's put it back to Light Steps. So let's look at another tag. We've got the script tag. So here it looks like I'm opening a script. So there's my opening tag. And here's my closing script tag. And a script tag is going to be extremely important because that's where we are going to write JavaScript code, our programming language for our games. But if you look in between those two tags, there's no code in here. So what is the point of this JavaScript tag? Well, it's extremely important because in our opening script tag, we're bringing in an external library of code. We're actually bringing in and importing a bunch of pre-written JavaScript. And that pre-written JavaScript is a library called the P5 library. And this P5 library helps us render graphics to our web browser. So we're going to get access to a bunch of functions that are going to help us draw things in our game from this P5 library. And so let's go look at it. What are some things we're rendering to the screen? Well, we're rendering our player, we're rendering these platforms, we're rendering our background, we're rendering this HUD or heads-up display, we're rendering text. All of those things, we get nice little helper functions to make our life easy using the P5 library. Okay, so let's go down a little bit more. We got a head. So look, here's our opening head tag. Here's our closing head tag. So we opened and closed. I got a body tag. Ooh, another script tag. And it looks like here we've got some stuff in it. So if I scroll down, where's the closing script tag? So I scroll all the way down. Whoa, I'm going, I keep 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 going. And eventually we close that script tag. So in between that opening and closing script tags lies all of our own personal JavaScript code that is going to represent our current state of light steps. So this is where we are going to work. Now, let's go see what we have in this JavaScript tag. So a nice little thing here, over here on the scroll bar, you can click in your code to jump where you want to go. So I'm going to jump back up here to the top of our code, line 17, where we open our script tag. So it says light steps, lesson 1, the world and player. So we get our little title. And then we have this thing called a mission checklist. Our mission checklist is going to be 8 specific things that we are going to do here in this lesson to take our terrible, terrible, terrible version of our game. Did you forget what it was? Our terrible, terrible version is this right here, this purple monstrosity where we cannot move at all. And we are going to make it much better. Now, we are going to solve each of these missions together. And every time we do, we're going to implement some new feature into our game and hopefully learn a little bit about computer science, programming, and game development. So let's go down a little bit more. We enter something called the student edit zone. And it says here that this is safe to modify. So when we're in the student edit zone, we have the freedom to change our values of variables. And we should not break our game. So if we look here, we got a bunch of things that we can change. And some of our missions put us in here. So it looks like we got to target like the player's speed, our platform width and height, our colors. We've got like color palettes, so like our background color or our text color, our player's color. And then we end the student edit zone. So anything in here, we are safe to change. Think of these like little dials or knobs that we can turn to tune how our game looks, plays, or feels. So, this is a great place to experiment. But the student edit zone does come to an end. So here's the end of the student edit zone. So once you go beyond that, changes that you make out here beyond the student edit zone could potentially break your game if you don't make the changes correctly. But we will go through and make lots of changes out here, but we'll do it together. And if you find that your game is broken, you have the final version of the code that you can open up and reference to double check yourself. So let's see what's outside the student edit zone. All right, so it looks like we defined some gameplay variables. So we've got player and platforms. All right, so we'll talk more about those things. And then we've got some functions. And so a function is going to be really powerful for us. We're going to do functional programming for our game development here. Essentially, a function is just a way to chunk a bunch of code together to run all at the same time or run concurrently. So right here, I've got 3 lines of code. If I wanted to run those 3 lines of code, let's say 5 times, I would have to write, 3 lines, 3 lines, 3 lines, 3 lines, 3 lines. That's 15 lines of code. Instead, I can just put them in a singular function. This function is called the setup function. And when I want to run those lines, instead of having to write all of those lines of code over and over again, I just call this one singular function. So I can say, hey, setup function, go run your code, and it will run all of that code. Now, these 2 functions are extremely important, and it's when we got to understand their use case here, because these are part of that P5 library that we imported in our first JavaScript tag. The setup function is something that gets called automatically from that P5 library when we start our game. So anytime I refresh my page or I start my game up, this setup function gets called. And in here, we are creating a canvas that has a specific width and a specific height. We are setting the font for our game and then we are calling some function reset game to defaults. And we'll look at that in a little bit. So basically, setup runs once right when we start our game. So refresh the page and it runs. The draw function, on the other hand, which is part of the P5 library, runs every single frame of our game. So this gets called automatically every time a frame is processed. So if we think about our game, if our game is maybe running at 60 frames per second, 60 FPS, that means this function is getting called 60 times in a single second. And each time it gets called, it is doing two things. It's calling a function update player, and it's calling a function draw scene. So those are going to be crucial for us moving forward. Now let's see what else we got here. We got our own personal functions. So these are functions that we are writing that we have to explicitly call. P5 is not going to do it for us. So we've got one called reset game to defaults, generate platform data, spawn platforms, reset player, update player move, get input direction, draw scene, which looks like it's drawing our background, our platform, our player, and our HUD. So there are draw background, draw platforms, draw player, and draw HUD. So it looks like, I just want to stress this, it looks like we've got like 3 different layers here for our game development. Layer number 1 is we got to define our data. So it looks like we're defining data in our student edit zone. We're setting a bunch of variables here, right? So that's defining data, and we're defining our gameplay variables. And then we have to update that data. So if we look, I've got functions like we're spawning platforms, so we're creating and updating those platforms. We're updating our player move. And then we have some functions that are all about drawing things. So we got to draw our data. So we're drawing our background, our player, our HUD, our platforms, that kind of stuff. So our 3 layers of game development here are going to be define your data, update your data, and then finally draw your data so you can see the changes to the screen. So with that big overview here, let's actually get into mission number 1. So mission number 1 says we got to change the background color of the area. All right, so how do we find where this mission exists in our code? Well, you hit Command F or Control F, and what it's going to do is open up this little search bar right over here. And this mission 1 is a tag. It only appears twice in your code. It appears once in mission checklist, and if you type mission 1 right here, it appears a second time in the code where the lines of code are for that mission. Now, you have these little up and down arrows. You can move between each instance of those tags. So if you're up here, you just hit down, and it brings us to our mission. So our mission number 1 says background color. We got to change the background color of the arena. Observe how it changes the mood of the world. So our background color is probably something that we should be able to change that won't break our game. So this finds us in, perfect. It finds us in the student edit zone. So this is something that we are free to change. We just have to understand what this line is actually saying here. So if we look, there are 4 things on this line that we're going to quickly talk about. First, we define a variable. Our variable is named BG_color for background color. And when you define a variable, you have to declare it. And we are declaring it as a const or a constant variable. What that means is that once we define this variable, over the life of that variable, its value will not change. So once we set the background color, we're not actually going to change it at all, which is why we declare it as a constant. Once my game starts, its background is always going to be the color that I make it. So we indicate constant variables by making them all capital letters. That's just like the general convention. Then I have an equal sign. An equal sign here, single equal sign, assigns a value to our variable. And the value that I'm assigning is right here. Hashtag 5529A1. And this is inside of quotations. And anything inside of quotations is known as a string data type. So we have a string. But this is an important type of string. It's a string that starts with a hashtag. And what that hashtag tells us is that this is a hexadecimal string. So we've got to understand what exactly is hexadecimal. Well, a hex string or a hexadecimal string is one of many ways with which we can define colors. And it uses the hexadecimal number system. So you are familiar with the decimal number system. You guys know how to count from, say, like 0 to 9. So let's write that out. So we have 10 numbers in our decimal number system. So we start counting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I've run out of digits, right? There's no more digits. So what do I do for the next digit? Well, I go back to the beginning. I already started at 0, so I shift, and now I start with a 1 here. So I'll say 1, and I put my beginning digit back in. So 1, 0. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. And I would continue till I get to 1, 9. And then I run out of digits. So I go back. I already use 0. I already use 1. So then I put 2 in the front. 2, 0, 2, 1. And that's how we count. Well, hexadecimal is no different. Hexadecimal, however, instead of having 10 digits to work with, 0 through 9, it has 16 digits to work with. 0 through 9, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it also has the letters A, B, C, D, E, and F. So in hexadecimal, the letter E represents the number 14. The letter A represents the number 10. But what do I do now? I ran out of digits, right? I ran out of my 16 digits. So what do I do for the next number? Well, we do the exact same thing we did with our decimal number system. We go back to the beginning. We already used 0. So now I'll start with a 1. And then I'll go back, 1, 0, 1, 1. So what we have here in hexadecimal, the number 1, 0 represents 16. The number 1, 1 represents 17. And we can go on and on and on. And typically for color, we go all the way out to the number 255. And the number 255 in hexadecimal is FF. Now, this is going to help us because this hexadecimal string actually is made up of 3 color channels. It's made up of red. And our red value right now is the hexadecimal number 55. It's made up of a green channel. And our green hexadecimal value is 29. And it's made up of a blue channel. Our blue channel is A1. So if we look here, of our 3 colors, we have the most blue with a little bit of red and not a lot of green at all. The green is extremely low. So let's use this understanding of hexadecimal strings to now change our background color. Let's up the blue completely. So I'm going to take this blue channel, which is at A1, and make it FF. And then let's wipe out the red and the green. So I want no red, 0, 0, no green, 0, 0. And let's see, our background should be a pure blue. Ooh, there it is. So that worked quite nicely. What would happen if we make the red channel fully on? So now we're turning the red channel fully on. Well, red and blue would fully make, ooh, that makes like a nice like magenta color. But that's way too bright for me. So if I want to dull the brightness, I could lower the intensity of these colors. Let's bring them down to like 8, 8 and 8, 8 in the red and the blue. And so now that's a duller version of that color. All right, so this looks really great. What if I put all 3 channels all the way on? So give me all the red, all the green, all the blue. When I do that, ooh, I get white. So that's going to make white for us. What if I say none of the colors? Give me none of the red, none of the green, none of the blue. Well, 0, 0, 0, 0, 0, 0 is black. Ooh, that actually looks kind of cool. I sort of like that. That's not my go-to here, but that's actually looks pretty good. Let's set a color. Let's decide on a color. I think I want a darker color. So we're going to say in the, let's do 0, 6, so just a small bit of red, 0, 9, just a small bit of green, and then 1, 3. So more blue than anything else. And let's see what it gives us. Ooh, there we go. It's like that dark color that I want, but now it's got a tint of blue, and giving like a nighttime vibe. So that's kind of cool, and it makes the color of my platforms really stand out. So I am very happy. Mission number 1 is in the books. Now, before we go on, you might notice there's another color right here. Well, this color is called an RGBA color. This stands for RGB alpha, and this represents 3 color channels, red, green, and blue, but instead of using hexadecimal, it uses decimal values, 0 to 255. So we have 76 in the red, 110 in the green, 150 in the blue, and then this last number, which is 0.18, is called the transparency. It's a number between 0 and 1. If it's set to 1, it means the color is not transparent at all. You won't see behind it. So if I set this to 1, our grid lines really are solid. And if I set it to 0, it means it's fully transparent. You'll see completely behind it, and now you can't even tell that they're there. But anything in between, like 0.1, what did I have it at? 0.18, is going to give you a slight transparency, so you can sort of begin to see behind it. So when I work with colors, if I'm just doing a solid color, I use a hex string, and if I'm going to use transparent colors, I use RGB alpha strings. So let's head to mission number 2 now. Let's see what mission 2 has to update. So mission 2 finds us in the update player move function. It says player position update. Update the player's horizontal position. Use player speed to move the player along the platform. Okay, so if we look here, this finds us in update player move, which this function is getting called inside of a function called update player. So you see right here, update player has one line of code. It says run update player move. And so here it is. We're running this function. And we're calling update player, I believe, if I jump, you can say here, I'll jump up to my P5 functions. Where are my P5 functions? We're calling update player inside of that P5 draw function. This is running every single frame of our game. So every single frame of our game, draw runs, and it calls update player. Update player then calls update player move. So right now it's saying, hey, we got to change the player.x. So what is player.x? Well, let's go look at our gameplay variables. So I'm going to jump to where our gameplay variables are, which puts me right outside of my student edit zone. Our player variable right here is defined as an object. So there's these curly brackets here. So an object has properties, and our player has 2 specific properties we can target. Their X property, which represents their X position in the game, and their Y property. So right now, if you look, there is our player. And our player's X property, if he's a rectangle, is going to be the left side of him, and its Y property is going to be the top of him. And right now, you might say, well, wait a minute, we set the X position to 0 and the Y position to 0. And you'd be absolutely correct. But if I scroll down, we have a nice function here called reset game or reset player. And inside reset player, we are taking their X position and we're changing it. We're putting it somewhere on, I guess it's called safe platform, and we're changing its Y position and putting it on a safe platform. So we can change these properties. And it looks like that's exactly what we have to do in mission number 2. So it says update the player's horizontal position. So we're going to take player.x, that's their horizontal position, and we're going to add to it. Right now we're adding 0. Well, we don't want to do that. It says we should use player speed. And notice how player speed is all capitalized here. This makes me think it is a constant. And if it's a constant, it probably is in our student edit zone. So you can stay here, but if I come to my student edit zone, I can see I've got a constant variable called player speed that's currently equal to 2. We'll eventually target it and change it, but for right now, let's just use that variable, player speed here. So we're going to add player speed. Player speed. Now look, as soon as I start typing player, I get this huge list of options. If I use my arrow keys, I come down to player speed. You can hit tab to auto-complete that line for you. Such a powerful, powerful tool. So now, let's see. Every frame of our game now, my player's X position should be increasing by our player speed, or 2 pixels. Let's check it out. If I refresh my game, hey, that's not actually good. Player, come back. Come back. He's just drifting completely off the screen because he's always encountering this movement. We don't necessarily want that to happen. So let's go see what mission 3 is going to have us do. Mission number 3 says we got to get our input direction. It says, okay, add the horizontal movement using a similar pattern. Support A, D, or left, right keys. All right, so we are creating a variable here, dx, and it's equal to 0. Note we're declaring it with let. Let means that the variable that we are about to create is going to change over its lifetime, because dx right now, which stands for a change in our x direction, is equal to 0. We are going to say, hey, let's assume we don't want to change our x position at all. But now what we'll do is we're going to ask a question. And the way we ask a question is with an if statement. And you put your question inside of these blocks, right? Inside of our parentheses. And if the answer to this particular question is yes, we're going to take that dx variable and we're going to subtract 1 from it. We're going to do minus equals 1. So if this question is true, then this line of code right here will run. So the question that I'm going to ask is the left arrow key being pressed or is the A key being pressed? So is A being pressed or left arrow key? And if that's the case, we're going to set dx to -1 because I want to move to the left. So how do I ask that? Well, there's a nice little function that will check when a key is being held down, and it is called key is down. So we're going to ask that question, and the A key has a key code. Every key on your keyboard has a key code. A's is 65. So we want that, or 2 vertical bars means or, and we'll say key is down, and then we'll put in left arrow so that we can name directly. So this question says, hey, is the A key being pressed or is the left arrow being pressed? And if either of those questions is yes, then we will set the dx value to -1. But we're going to ask another question. We're going to say, well, wait a minute, what about our right arrow and like the D key? So let's ask another question. And if the answer to that question is yes, then dx, instead of subtracting 1 to move to the left, will add 1 to indicate that we want to move to the right. Our question is going to say, hey, key is down. Are we pressing a key? And the key code for D, the letter D, is 68. Or our 2 vertical bars, key is down. And this time we're going to spell out right arrow. All right, so I think that looks great. So let's see if we can implement this in our game. Can we move our player left and right now by pressing our arrow keys and changing these dx variables? Let's see. All right, so here he goes. Oh, our player's got a mind of its own. It's still just drifting off the screen. Well, why is that? Well, if you look, we're making these changes to this dx variable, indicating, hey, we want to move to the left or move to the right. We want to change our x position to the left side or the right side inside of this function, get input direction. But you just saw, if I scroll up just a little bit, inside update player, we are just simply always adding +2 to our player's x position, independent of what we're doing with our keyboard press. So we somehow have to link these two functions together. And if you look here, the first line of code we have in update player move calls get input direction. So that's going to be really important here. And it looks like we're creating a variable called input direction and setting it equal to that function call. So when this happens, our function get input direction, which is where we define our little variable dx, which is keeping track of whether or not the player wants to be stationary, not moving, moving to the left, or moving to the right, we then have this really powerful line right here, return dx. So that variable dx that we just created, we are returning it. What that means is we are going to give that variable back to whoever called this function. So if we look, our variable dx is going to go right back here where we called it inside of update player move, and we're setting it equal to a variable input direction. So inside of our function here, input direction is now going to be 0 if the player is stationary, -1 if the player is moving to the left, and +1 if the player is moving to the right. Which means when we update the player's speed, I really want to take that value, which is 2, and multiply it. So we're going to I'll multiply it in the front. We'll do input direction times our player's speed. So if we want to be stationary, this is going to be 0, and 0 times 2 is just 0, so we shouldn't change our position. If we want to go to the right, this is +1, so +1 times 2 is +2, so we move to the right. And if we want to move to the left, this is -1, so -1 times 2 is -2, and we should now move to the left. I think our input system is going to work now. So let's see, ooh, our player is completely stationary. I'm going to press the A key. Let's see what happens. Ooh, I move to the left. I'm going to press the D key. I move to the right. The left arrow key. The right arrow key. This is perfect. Oh, except I can fly off my platforms. But we are beginning to see this input system working here quite nicely. Hey, mission number 3 is done. Let's go to mission number 4. Mission number 4 says, ooh, we have to generate a platform in our arena. It looks like I got a missing platform. 1, 2, 3. Well, nothing right there. So we want to generate that platform. So how are we going to do that? Well, mission number 4 finds us in a function called spawn platforms. Okay, so let's see. It looks like I create a bunch of variables here that just define positioning. Left X, left bridge X, center X, right bridge X, right X, top row, upper safe row, Y, center row. So these are all positioning. And then I have a bunch of these commands, platforms.push, 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 platforms.push. So we got to talk a little bit about what those lines of code are doing, because we got tons of them here. So I am going to move to my gameplay variables section where I define my gameplay variables right outside of my student edit zone. We already talked about our player object, so this is really good. But now we're going to talk about our platforms variable. And our platforms variable is defined by these square brackets. Those square brackets are an array. So we have an array data type. And I like to think of an array as a container, all right? A container to hold objects. So right now, our platform array has nothing in it. It is completely empty. But what we'll do is we will create various platforms and we'll put them in the array. So I'll say platform 1, platform 2, platform 3, platform 4. We'll create all of these different platforms. And what's super nice about this is if I want to do operations on each of these platforms, instead of writing the code 5 times to target 5 different platforms, I'll write the code once to target everything in the array. And we'll apply the code to this platform, then this platform, then this platform, then this one, and then this one. One last thing about arrays, everything in here is at a certain position in the array. So this is at position 0, at position 1, at position 2, at position 3, and at position 4. And with arrays, we have this really nice power where we can type the array's name, so platforms, and then we just put little square brackets, and we can reach in and grab whatever is at a given position. So if I put, say, 3 in here, I'm going to reach into this container, and I'm going to grab what is at position 3, and now I can work with that particular platform. All right, so that is the power of arrays, and we're going to see that quite a bit. And it looks like we're going to use those here in mission 4 because we have 2 functions working here together, a generate platform data and a spawn platforms. So right now, it looks like we are taking our array, which is called platforms, that's our container, and we're calling the push method, so dot push. That means we are about to put something into our array. What are we putting into our array? It's whatever's coming back from generate platform data, that function. And see, generate platform data is returning something to us. It's returning an object that represents a platform. It has an index, an X value, a Y value, a width, a height, a color, an is safe property, a has enemy property. So all of these properties combine to create our platform object. And that object gets stored in our container. All right, so let's go down and let's just mimic it. It looks like these are all sort of the same. So let's mimic our last missing platform. So down here, mission 4, we're going to target our array, platforms dot push, and then I'll call the function generate. I'm going to do tab for autocomplete here, generate platform data. All right, and I got to put a bunch of stuff in here. So let's see. The first thing I need is an index. And then I need an X and a Y. So let's see. Well, my indices are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess I'll do 10. Yeah, let's do 10. And then what do we need here? Well, let's see. Our X values, we got left bridge X, right bridge X, left bridge X. So I'm thinking this is left bridge X, right bridge X, left bridge X. We probably want right bridge X. It's sort of like a bridge, to another platform. So let's put in the variable right bridge X, one of those positioning variables, right bridge X, tab for autocomplete. And then I think we're going to be for our Y position, if we look up here, we had upper safe row Y, lower safe row Y. This is going to be our lower safe row. So we'll type lower safe row Y, lower safe row Y, tab for autocomplete. And then what else do we need? So if I scroll back up here, we need a width, a height, and a color. And then it is safe and has enemy. So width, height, and color. Okay, so our width, let's see what we did earlier. So I just scroll over here. Our width is going to be safe bridge width, tab for autocomplete. Our height is going to be safe bridge height. I'm going to scroll and do tab for autocomplete on that first one. And then we'll do safe platform color. So that's our third one down, tab for autocomplete. Now, I think this is going to be, it looks like we're using, this is like a safe place to stand, right? These ones are going to be our safe platforms that we can use to move to some of our other ones. So the is safe value we will put as true. All right, so we'll say, and we'll put true. All right. I think this looks pretty good. Now look here, the has enemy is automatically set to false. I don't actually have to take that in. I don't have to pass that into this function. So these are the pieces of information we have to give this in order to work. I don't need to pass in has enemy because we are going to create our platforms with no enemies on them to begin. All right, let's see if mission 4 is done. I'm going to put a little semicolon here right at the end, though, to get good JavaScript. We'll refresh the page, and boom, there is our missing platform. Oh, that's great. That works really cool. So we can spawn platforms nicely here and add them to our array. Mission number 5 says we got to change the player's color. Yeah, he doesn't look that good. So mission number 5 finds us back up here in our student edit zone with all of our colored constants and our color palettes. So we are going to change the player's body color and their core color. So we are going to set the body color. Let's get rid of this and let's set it to F4. So a lot of red, F7, a lot of green, and FF, a lot of blue. So a lot of red, a lot of green, a lot of blue. We should be white. And I like that. That looks pretty good. But then I want to change this core color because right now it's like a burnt orange. That's not working for me. So I'm going to set FF, all the red, AA, a lot of green, and 5A, a medium amount of blue. So let's see what we get. And that's going to be like a little yellow color. So a lot of red and green give you that yellow. So that's kind of like a yellowish orange. I am pretty happy with that. Kind of looks like a fried egg. We got a fried egg as our player. All right, mission 5 is done. Mission number 6 says let's increase the player's speed. Yeah, because right now he's not that responsive. So player speed, that should be one of our constants in our student edit zone, and we find it right up here. The player speed is currently set to 2 pixels per frame. So every frame we're moving 2 pixels. Let's set it to 20. Let's see what happens here. Pixels per frame. Well, he's a little bit too fast. That's a little too fast. And we can zoom right off the screen, so we don't like that. Let's lower it. I'll pick 8. 8 pixels per frame. Does that seem reasonable? Yeah, that seems pretty good. That's responsive. I like that. So, but this is bad. Like, we don't want him to be able to go off the screen. So we got to kind of limit his movement, I think. And so let's take a look at mission number 7. Mission number 7 finds us in our update player move function. Remember, this is where we actually are moving the player. So we're actually moving the player right there. And we got to set a world boundary rule. It says keep the player on the safe platform. So we're actually going to make sure that they don't leave the platform, that starting platform. So let me restart my game right here. We're going to keep them on this safe platform. So we got to set and say like, hey, if your left side goes beyond this platform, get back on the platform. If your right side goes beyond, or if your left side goes beyond this platform, get back on the platform. We're going to keep you right here. And the way we're going to do that is with the constrain function. So we're going to target the player's X property, and we're going to call constrain. To constrain something means to limit it between a lower and upper value. So we are going to put in 3 pieces of information here on the constrain function. First, the thing we want to constrain. We want to constrain the player's X property. And then we have to put the minimum and maximum value that we want to use for this. So like imagine if I did 0 and I did the width of our canvas. So let's just test that out, 0 and width. So if I refresh the game, hey, I'm constrained. I can't go beyond that. And I guess I can sort of go beyond that. Well, what's happening is we're referencing the left side of the player. So the player is going off the screen and the left side's right here. So if I want, I could do width minus, I think we have a variable called player size. Let's subtract the player's size. And so now, if we test this out, boom, we're constrained over here as well. But we want to apply that logic not to the edge of our screen, but to this particular platform. We got to keep them on the platform because eventually gravity is going to take us down, right? Gravity is going to take us down. So what we'll do, it says you can use constrain to stop the player from leaving the walkway. We've got a couple of variables right up here. We've got min x, which is our safe platform's X variable, and max X, our safe platform's X player variable, plus its width, minus the player size. See, we're taking that player size off here. So let's use those variables, which are for that platform that we are on. So min X and max X. And so now when we put those in, I believe we are going to be confined to that safe platform. Can't go off there, can't go off there. Perfect. So now I'm confined, and I would have to jump to get to the next one. So we got to maybe get that jumping system down in one of these videos. Mission number 7 in the books. And our last mission, mission number 8, is all about drawing information in our HUD. Right now, our HUD, or our heads-up display, is getting called because drawScene, this function, draws our background, our player, our platforms, and our HUD. And this is getting called inside of that P5 library draw function. So our default P5 draw function, which runs every frame of our game, updates our player, and draws our scene. Now, inside draw HUD, what are we doing? Well, the first line here, no stroke, says give me an invisible marker so you do not see the color or the outline of the shape that I'm about to draw. So we're going to draw a shape, but we get an invisible marker so you don't see its outline. And then we call the fill command, which says we are going to put some paint into a bucket and we're going to paint the shape that we draw. And the color that we use is an RGB alpha string, 0 in the red, 0 in the green, 0 in the blue. That is black with a 0.7 transparency. So we are going to be able to see slightly behind it. See, we got a nice little transparent black up here. Now we draw a rectangle using the rect function. This takes 4 pieces of information: the x coordinate of the top left point and the y coordinate of the top left point, the width of the rectangle and the height of the rectangle. And we're using our HUD height constant of 60 for that height. So I start here in the top left corner, I go all the way to the edge of my screen, and then I go down 60 pixels. And that makes my HUD rectangle. So that looks really great. Then we put a new paint in our paint bucket, our text color, which is sort of white. It's got like almost all of our color channels, all the red, all the green, all the blue. And then we are aligning our text in the left position, in the horizontal, and to the center in our vertical. And we're setting our text size. This is like priming us to create text. So like watch what happens if I switch this. Let's just make this like bigger. I'll set this to be like 60. So now our text size is bigger, which looks really kind of silly. So I'm going to change this back to 18. The left alignment here says when we position this text, we're going to position this G character over here on the left. If I make this center align in the horizontal, now we'll position it by the center of the string. So like our space is probably going to be where the G is. Let's take a look. Yep, see, and our space is basically where the G was. So let's change that back though, because I want left aligned. All right, and so now once we prime for text, we just got to create our text. So we call the text function. And here we take 3 pieces of information: a string that we want to display, its x position, and its y position. So I like the x position and the y position. 15 pixels in, boop, and 25 pixels down. So when we start talking about pixels, the top is 0 pixels, and then you increase going down. The left is 0 pixels, and you increase going to the right. So let's change our string name here to our actual game, Light Steps. And then let's see where that puts us. All right, so I think we are all set here. Our world is created. It looks really good. Our player is created. We have a nice input system. This is a perfect place to stop. So we did some really cool things here. We created the world. We built out the feeling that we want. We have that nice dark background with our platforms spawning in our arena. So it gives us the layout, which we'll eventually use to move our player by jumping off platform to platform. So we'll continue building on this in our next video. I'll see you then.